expanding Starlink's reach. The impact of 23 new satellites. Ultra-long news feature on SpaceX's June 10, 2025 Starlink launch. In a powerful continuation of its orbital dominance, SpaceX launched yet another batch of Starlink satellites into low Earth orbit, LEO, on June 10, 2025, further solidifying its status as the world's most prolific commercial space operator and global communications enabler. The mission, officially designated Starlink Group 6 to 66, saw a Falcon 9 rocket rise from Launch Complex 40 at Cape Canaveral Space Force Station at precisely 9:05 a.m. Eastern Daylight Time, carrying 23 new Starlink satellites, 13 of which were equipped with the company's groundbreaking direct-to-cell (DTC) technology. This mission wasn't just a routine deployment. It was a critical step toward realizing Elon Musk's vision of providing ubiquitous mobile connectivity. From remote jungles to polar ice caps, mountaintops to mid-ocean shipping lanes. The next leap in Starlink evolution. Since its debut in 2019, Starlink has grown from a modest constellation of demo satellites into the largest satellite communications network in human history. With the addition of this latest deployment, SpaceX has surpassed 6,300 operational Starlink satellites, a number that dwarfs all other commercial satellite operators combined. But the June 10th launch distinguished itself by including 13 direct-to-cell units, signaling a massive technological and service milestone for the company. These advanced satellites are designed to communicate directly with ordinary mobile phones, without the need for ground-based cell towers or external receivers. By leveraging the company's agreements with telecom partners like T-Mobile in the US, Optus in Australia, and KDDI in Japan, the DTC satellites will enable basic services, like SMS and eventually voice data, anywhere on the planet. This transformative capability has long been sought by both telecoms and governments, but was traditionally limited by hardware, cost, or regulatory hurdles. SpaceX's approach removes the most difficult barrier: the need for dedicated infrastructure in hard-to-reach locations. Now, fishermen lost at sea, hikers stranded on remote trails, villagers in the Amazon, or aid workers in disaster zones will have the ability to connect using standard smartphones, even with zero terrestrial coverage. By launching and operationalizing DTC satellites at scale, SpaceX is creating a parallel communications ecosystem, a kind of orbital safety net that could reshape how humanity thinks about mobile connectivity. Booster B1083. Reusability in action. The launch was powered by Booster B1083, a veteran Falcon 9 first-stage rocket that successfully completed its 12th flight, underscoring the increasing maturity and reliability of SpaceX's reusable launch system. After lifting the payload into the initial phase of orbit, B1083 separated cleanly and descended back through Earth's atmosphere, executing a precise landing burn to touch down aboard the autonomous drone ship. Just read the instructions, stationed off the Florida coastline in the Atlantic Ocean. Each Falcon 9 booster is designed for at least 15 to 20 flights with refurbishment between missions, and B1083 is approaching the outer edge of its current operational range. Its recovery reinforces the cost savings and logistical advantage that SpaceX enjoys over its competitors. Instead of expending massive sums on single-use rockets, the company recycles boosters with incredible efficiency, lowering the cost per launch, increasing cadence, and pushing innovation cycles forward faster than ever. The successful recovery also allows for data collection and analysis, informing future designs and extending vehicle longevity. It's not just about returning a rocket, it's about evolving an entire industrial process. Starlink's strategic momentum in 2025. This mission marks SpaceX's 41st Falcon 9 launch of the calendar year, 27 of which have been dedicated to Starlink deployments, highlighting the sheer pace of satellite expansion in 2025. The company is targeting over 90 Falcon 9 flights this year, with several Starship test flights and Falcon Heavy missions also on the horizon. The speed at which SpaceX can prepare, launch, and recover its hardware has created a flywheel of capability, enabling faster satellite iteration, denser orbital infrastructure, and real-time expansion of global service coverage. With hundreds of ground stations already operating and dozens more under construction, Starlink is poised to increase data throughput, reduce latency, and improve resilience in regions plagued by unstable networks or insufficient infrastructure. The deployment of laser interlinks, optical communication links that connect satellites in space, further improves performance in remote areas where ground stations are impractical. SpaceX's continuous upgrades to satellite bus design, power efficiency, and radiation shielding also enhance operational lifespan, service reliability, and planetary coverage. A global utility for the 21st century. The implications of this connectivity revolution reach far beyond consumer internet. In areas hit by natural disasters, where floods, earthquakes, or hurricanes destroy terrestrial infrastructure, Starlink can serve as the first line of reconnection, powering everything from emergency services and disaster relief to school systems and local government operations. SpaceX has already deployed Starlink terminals in response to humanitarian crises in Ukraine, Haiti, and Chile, often restoring essential communications within hours. With DDC technology, the system takes a leap beyond terminals. Imagine a firefighter entering a smoke-choked forest, or a paramedic traveling through mountainous terrain, both now able to send messages, GPS coordinates, or alerts via regular cell phones. The satellites overhead will act as orbital base stations, routing their calls to the nearest cell network or Starlink ground relay, creating a digital lifeline that bypasses the fragility of traditional systems. For maritime and aviation industries, the benefits are just as significant. Ships traversing the Pacific or planes flying polar routes currently rely on spotty and expensive satellite links. With Starlink's next-gen satellites, airlines will be able to offer seamless, high-speed connectivity across the globe, and shipping companies can monitor, route, and communicate in real time across oceans. Moreover, the rise of autonomous vehicles, oceanic drones, and airborne UAVs will increasingly depend on reliable orbital connectivity, something Starlink is uniquely positioned to offer. Regulatory, competitive, and scientific horizons. SpaceX's aggressive expansion is not without challenges. Regulators in several countries continue to scrutinize Starlink's orbital density, electromagnetic interference potential, and compliance with national telecom rules. Competitors like Amazon's Project Kuiper, OneWeb, and China's Guang constellation are rapidly developing their own solutions, prompting a global race for LEO dominance. However, SpaceX's first-mover advantage, combined with vertical integration of launch, satellite manufacture, and ground infrastructure, makes it uniquely capable of responding to technical, economic, and political pressures. Additionally, as astronomers voice concerns about light pollution and satellite trails impacting Earth-based telescopes, SpaceX has responded with darker paint, anti-reflective coatings, and adjusted orbital altitudes. The company is also engaging with the global astronomical community to mitigate observational interference, balancing technological advancement with environmental responsibility. On the scientific front, Starlink's infrastructure may soon enable real-time Earth monitoring, climate modeling, and disaster detection, using the same orbital pathways for sensing as well as signal relay. By adding multispectral or environmental payloads to future satellites, SpaceX could evolve Starlink into a dual-use platform, supporting both commercial and scientific missions at a fraction of traditional satellite costs. A new chapter in human connectivity. In the final analysis, the June 10th Starlink mission is not just a story of rockets and satellites. It's a story about redefining what it means to be connected in the modern world. It's about collapsing the barriers between remote and urban, poor and wealthy, developed and developing. It's about turning space into an extension of our public infrastructure, just as roads, power grids, and water systems once defined our civilization. With 23 more satellites orbiting above us, 13 of them bringing direct-to-cell capability. The world has grown just a little smaller, a little more accessible, and a lot more resilient. SpaceX's constellation now operates not as a dream of the future, but as a present-day utility, blanketing Earth in invisible beams of potential for communication, education, safety, and opportunity. The rocket may be silent now. The booster is resting aboard a drone ship. The launch pad is being readied for another flight. But above, high in the quiet night sky, 23 new stars are moving in sync, carrying with them the message that the age of global, orbital connectivity is no longer a vision on the horizon. It is here, it is growing, and it is only just beginning